Welcome to this video on cumulative frequency. Now we have a question here about a company selling clothes online, and they are checking on the productivity of the workers. And this data shows the number of orders packaged by the workers. So 4 of the workers packaged between 40 and 45, 17 of them packaged between 45 and 50. This is on a particular afternoon, and so on. These 7 people packaged between 70 and 75 during that afternoon. Okay, and we're going to now plot or complete rather a cumulative frequency table for that data. Well, this is quite easy. It's like a running total. So 4, we add the 17 on, and that gives us 21. Then we add the 33 on to give us 54. Add the 25, 79. Then we get 99. Add on the 14 to get 113. And finally, we finish at 120, which is the number given in the question. So we got a pretty good idea that that's right when we see that 120 there. So that's really easy. Okay, then we come to draw the cumulative frequency graph. Now, a few rules about this that you need to follow. The first thing is that you plot the end point of the class interval against the cumulative frequency. Okay, so I'm plotting 45,4, not the midpoint. 45,4 is approximately there. Okay, now obviously it's going to have some room for error because of the small scale on the graph, but do the best you can. Okay, 50 and 21 is going to be about here. Okay, about there. Okay, then we have 55 and 54. Okay, just under there, roughly there. Okay. And then we come to 79 at 60, so that's just under there. Okay, and then we have 99 here at 65. 113 is about here, and 120 is up there. Okay, now when you come to join the points together, you can do it in one of 2 ways. You can either have a smooth curve that you draw freehand, but you must visit all of the crosses, okay? Or you can have a series of straight lines with a pencil and ruler. Now, I'm going to do that option because it's really difficult on a tablet that's detached from the screen to draw a smooth curve. So I'm going to do the straight line option, okay? What you mustn't do is a line of best fit that misses some of the crosses out or just passes by them. It has to go through all the crosses. And the other thing you need to be aware of is it needs to start at the same distance back from of the class interval. So if the class intervals are 5, it needs to start 5 back from 45 at 40, not where the axis starts necessarily, okay? In this case, the axis starts a bit sooner than that. So we're going to start at 40 and do our first straight line to there like that. Okay, then I'm going up to here. Okay, then I'm going up. And it tends to get steeper around the middle of the graph. Okay, not always, but generally it tends to get steeper towards the middle and then starts to ease off again as you come near the end. Okay. And you can see that sort of shape forming, and even with straight lines it looks reasonably smooth as you come round. Okay, so that's what a typical cumulative frequency graph would look like. Now we've now got a question to answer about it. It says that you've got employees who packed 53 or fewer orders will have their productivity checked again. How many employees will this affect? Well, the way to answer this is to put the 53 clearly on the graph here. That's here, okay? Project a line up from the 53 until you cross your graph, okay, and then where you cross, project across here, and I read that off to be about 42. Okay, so you read off the number off the horizontal scale, and that appears to, sorry, off the vertical scale, and that appears to affect 42 employees. They will give you some leeway on this because of the accuracy of your own graph. Okay, so that's the questions answered so far. I've added an extra question here, part C, which is to use the graph to estimate the median and upper and lower quartiles and then draw a box plot for this data. Okay, well, this is how it works. I'm going to take this last bit off, okay, and we're going to move across to complete this question. So let me just take that off, leave the graph there because we'll need that. This can come away because I'm going to need that space in a moment. And the rest of this stuff can disappear as I slide this out the way. Okay, and we're now doing part C at the bottom here. Okay, and the question says we've got to estimate the median upper and lower quartiles, and this is what we do. All right, take a pencil and ruler and use I'm going to use a lighter color. I'll use the yellow color here, okay, but you would use pencil here. Now there's 120 data points, so the median is the middle one, the 60th one. So at 60 you project a line across, hit your graph, and then drop straight down, okay? And I'm deliberately going to just extend it through. You'll see why in a moment. Okay, and the upper and lower quartiles, so the lower quartile is a quarter of the way through the data. So it's taking me to about there, okay? And then I'm coming down to here, okay? Like that. And the upper quartile is 3/4 of the way. Well, 3/4 of 120 is 90. And that takes me to about there, which comes down to about there. Okay? But leave these lines showing clearly on your graph. Okay? Because they're part of your working out. Now, so I can say with some confidence that the lower quartile, I'm just going to use these abbreviations, is equal to, well, you see it's slightly over 51. I'm going to put 51 because they would only expect these to be to the nearest integer anyway. Okay, the median is going to be equal to, it's looking like about 56. Okay, and the upper quartile is showing us about 63. Okay, now, by the way, do not refer to the mean of the data at any point because you can't find the mean of the data from cumulative frequency information. So it's the median you're talking about, not the mean. Now, if you've got to draw a box plot, you just have to plot those 3 points onto your axis here for your box plot. But what I'm going to do here, you sometimes get this in a question, they give you a bit of the axes, the same scale immediately below. So the reason I've extended those yellow lines down is, although it looks like I'm going to have to extend them a bit further, let me just put that there. Okay, I can line that up underneath, you see, and if I can get that to come to the front, then we might be able to see it. Try and line them up as best I can. Okay, now I think if I put this, there it is. So you can see where those yellow lines have projected down. So I can just literally construct my box around that, you see. So if I go to here now, let me just choose to do this in blue. So the box starts at 40, the whisker starts at 40 and stops at the lower quartile. It resumes from the upper quartile to 75. Okay, in this bit we have the box. Doesn't matter how wide the box is or high it is, it just is a box like that. Okay, and then the three key points to show on the box are the lower quartile is the end of the box, like that. I'll try and do that one a bit more vertically, but you can see the idea, I'm sure. Okay, the median is that one there, and the upper quartile is the other end. Okay, right. Okay, so you've seen the idea, and you sometimes just have a little mark at the end of each whisker, but you don't have to do that like that. Okay, so the box plot shows what we call the distribution or spread of the data. Okay, and very typically the median is usually around the middle of the box, but if it's to one side, that means the data is what we call skewed. Okay, and so that's it, and I hope that was helpful.